Hello everyone, today I'll be talking about how to balance a chemical equation. I will provide a link to download the material and a link for the website where you can find more videos and more downloading materials. Chemical reactions and the chemical equations. The chemical reaction itself is a process in which a substance or substances is changed into one or more new substance. Chemists present those changes using what we call chemical equation. We use symbols to represent these chemical equations where we have the reactants on the left hand side and the products on the right hand side. Let's now try to write a chemical equation. Burning hydrogen gas in air that contains oxygen to form water. So I will represent hydrogen gas by H2 plus oxygen O2 to give me H2O. What I need first to look at the number of atoms on this left hand side and the number of atoms is in that side. So I could see here on that left hand side, let's just write it here again. I have here two hydrogen atoms and two oxygen atoms, and I have here two hydrogen atoms and one oxygen atom. So I need to multiply this part by a factor which is 2 to be able to have the same number of atoms on both sides for the oxygen. So I will multiply this one by 2, so the equation will become 2H2O. Now let's count again the number of atoms. I could see I have here 2 hydrogen atoms, 2 oxygens and 4 hydrogens. Usually the number on the left hand side is multiplied by both elements. So 4 hydrogens and 2 oxygens. Now I could see that the number of hydrogen here is not equal to that side, so I need to multiply this one by 2. If I multiply it by 2, this means I have 2H2 plus O2 to give me 2H2O. If I counted the number of atoms, here became 4 hydrogens and here 2 oxygens, and here 2 by 2 is equal 4 hydrogens and 2 oxygens. Now I have reached the final balanced chemical equation, which is this one. If I write it here again, I could see that 2H2 plus O2 give me 2H2O. This means I have 2 moles of hydrogens that reacted with 1 mole of oxygen to give me 2 moles of water. If I try to find out the grams of reactants, that would be equal to the number of moles, which is 2 moles, multiplied by if I know that each 1 mole of hydrogen contains 2 grams of hydrogen. I have to know here I have 2, so I have 2 atoms, so these 2 atoms, each one of them is 1, so I multiply by 1, which is equal to 2, plus I will do the same with the oxygen. So I have 1 mole of oxygen multiplied by the molar mass of oxygen, which is equal oxygen gas, which is equal to by 16 grams over here for O2. If I know that would be equal to 1 mole, so the sum of that would be equal to 36 grams. This means I have 30 grams of the reactants to give me this product. So let's now see how much product do I have. So I have 2 moles of water, so grams of product would be equal to 2 multiplied by the molar mass of H2O. So H2O, I have 2 hydrogens, each one of them is equal 1 atomic mass, and the oxygen, which is 16 multiplied by 1 oxygen atom. So this equal to 18. So each one mole of water contains 18 grams. So I should write here that I have 18 grams of water in each mole. If I calculated, this would be equal also 36 grams. We could see that the number of grams for both products and reactants are equal. So to balance a chemical equation, I have to follow certain steps. First, I have to identify all the reactants and all the products and write their formula in a correct way on both sides of the equation. So in that part, I would write the reactants, and in that part, I will write the products. Second, I have to try to balance the chemical equation by trying different coefficients and to make the number of atoms of each element the same on both sides of the equation. So if I have here 2 oxygens, I have to multiply here by a factor to obtain 2 oxygen as well. So my first possible way is to look at the elements that appeared only once on both sides of the reaction. In that case, if I have here, I could see that both of them, the oxygen and hydrogen, appear on that side of the equation once. But if I have one of those reactants that appeared on the product side more than once, or it appeared on the reactants more than once, so I just delay balancing this element and move to the element that appeared only once on both sides of the equation. So finally, I should check my balanced chemical equation and make sure that I finally reached the same number of atoms on both sides of the equation. Let's take an example. Balance the chemical equation heating potassium chlorate. So the decomposition of potassium chlorate into potassium chloride and oxygen. Here I could see that I have here one potassium atom, one chlorine atom, but I have here 3 oxygens and I have here 2 oxygen. So my first step would be multiplying by a factor to be able to balance this chemical equation. I will multiply this part of the equation by a factor. Here I will multiply by 3 and I will multiply here by 2. The aim for that, I have here 3 oxygens and here I have 2 oxygens. So if I multiply the 2 by 3, it gives me 6. So I want to reach the number of oxygen on that side to be 6 and from that side to be 6. So I multiply here by 2 and I multiply here by 3. So I have 2 KClO3 would be equal to KCl plus 3O2. Now let's count the number of atoms on both sides. So I have 2 potassium, 2 chlorine, 3 oxygens, and on that side I have 1 potassium, 1 chlorine, and 6 oxygens. Actually here I have 6 oxygens because I multiplied here by 2. So 6 oxygens. So the number of oxygens on both sides of the equation now are equal, but the number of chlorine and atoms and potassium atoms are not equal. So I have to multiply here by 2. Let's try now. So 2 KClO3 would be equal to 2 KCl plus 3O2. If I multiplied, if I counted the number of atoms on both sides, so I could see that I have here 2 potassium, 2 chlorine. So I have 2 potassium, 2 chlorine, and 6 oxygens. And the product side, I have 2 potassium, 2 chlorine, and 6 oxygens. So now I have the same number of atoms on both sides of the equations for each element. Now let's take another example. Burning natural gas C2H6O2 to give me carbon dioxide and water. I could see that I have 2 carbons and 6 hydrogens. On that side I have 2 oxygens, but on that side I have 1 carbon and 3 oxygen. I have 2 here and here 1, which means I have 3 oxygens and 2 hydrogens. If I try to balance this chemical equation, I will start by balancing the carbons and the hydrogens on both sides, because oxygen appeared on that side twice in the form of carbon dioxide and the water. So if I try to balance my carbons, this means I have to multiply the carbon dioxide here by a coefficient which is 2, and I have to multiply this part by a coefficient which is 3. So my equation will be C2H6 plus O2 to give me 2CO2 plus 3H2O. If I tried now to count the number of atoms, now I have 2 carbon atoms, 6 hydrogens, 2 oxygens, and I have here also 2 carbon atoms, 6 hydrogens, because I have to multiply this coefficient by the number here, so I have 6 hydrogens, and here I have 4 oxygens and and here 3 oxygens, which means I have 7 oxygens. So I could see that I have balanced my hydrogens and my carbons, but I still need to balance my oxygen. In that side, I could see that I have even number of oxygens, and I have here odd number of oxygen. To be able to fix that, I can multiply this oxygen by 7 and divide it by 2. So if I try to multiply this by 7 and divide it by 2, O2, it can give me the same number of atoms on both sides. So here I will have 2 carbons, 6 hydrogens, and 2 cancelled with the 2, so I have 7 oxygens, and here I will have 2 carbons, and here I will have 4 oxygen, and here 3, which means 7 oxygens, and 2 by 3, which is 6 hydrogens. But in usually we don't write a fraction in a chemical equation, so I have to multiply the full equation by 2 to get rid of this fraction. So I will write the final step in balancing this chemical equation. So I will have here 2 C2H6, and I will have here the 2 will be cancelled with this 2. This means I have 7O2 to give me, here I have to multiply also by 2, so I have 4 CO2 plus 2 multiplied by 3, which means 6 H2O. Now let's count the number of atoms. I have here 2 by 2, 4 carbons, and here I have 4 carbons. I have hydrogen here, 12 hydrogens, and here 12 hydrogens, and the number of oxygen here is 7, and the total number of oxygen, the total number of oxygen here is 14, because 7 by 2 is equal 14, and on that side is also equal to 14. And this is the last step. Another example, when aluminum metal is exposed to air, a protective layer of aluminum oxide is formed. The formation for this protective layer is, if we try to write it, it's aluminum and oxygen to give me aluminum oxide. So if I try to count the number of atoms for each element of those, I could see that I have 1 aluminum, and I have here 2 aluminum atoms. I have here 2 oxygens, and I have here 3 oxygens. The same way I have here odd number and here even number, so I have multiplied this by 3 and divided by 2 to get rid of this, to make the number of oxygen atoms on both sides the same. I also need to multiply this part, the aluminum, by 2, because I have here 2 aluminum. So let's write this equation now to give me Al2O3. If I counted the number of aluminum here, same to that side as well, and the number of oxygen here is 3 and here is 3, but usually I don't keep a fraction in my chemical equation, so I have to multiply this equation by 2. I have to remember to multiply this by each part of the equation, products and reactants. So I have 4 aluminum that would react with 3 oxygens to give me 2 aluminum oxides. Now we came to the end of this video. My next video will be on the reactions in aqueous solution. See you next time. Thank you and goodbye.